Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about wire ferrules and crimping system. Because last two episodes we talked about plugs and basically IEC socket. Now here's deal. Let's say you got the socket, you got the proper cable, everything is awesome. But here's deal, what happens behind the socket also matters. Meaning if this part is the weak link, then you are still not safe. You are still playing with some serious problem. What are these problems? Well, loose electrical connections are bad. I am reasonably sure most of you know about that. Now, what can happen if you have low connection, bad connection, so to say? You can have low reliability. Now, these sort of problems are really headache for people who are dealing with technician level equipments, meaning generally low voltage 48 volt subsystem, because it will create intermittency issue, meaning it works sometimes and other times it's like lol. No. So that creates a very serious issue. It's nigh impossible to diagnose. Sometimes people just like give up and just like undo the whole cable harness and redo it. That's the only way to fix it. So you can understand, like, that's a very serious problem. Then fire hazard. I'm reasonably sure that shall not want this in their home. So fire hazard part is very serious, and it's a single use issue, meaning if you have a cable and you stripped it and you just like coiled it over, folded it over, put it there, and you tighten it up. Here's the problem. The moment you pull it out, you will find copper is a soft metal, meaning inherently it will start to nick there. What does that mean? That simply means the once you pull out, you will look at it, it's like, bro, I don't think it's safe anymore. You will strip another. Here's the problem. Most electrical wiring does not have enough service loop that you can do it more than 1 or 2 times. So it makes it single use. So fundamentally, it's not something you want. And then you may think soldering has some serious issue. It's not practical, specifically when you have thick wires, specifically with copper. For example, if you have, let's say in my household, we have like around 4 square cable coming in. Be mindful, we are at 220 volts. So 4 square cable is coming in. If you try to solder that, good luck. It's not that it can't be done, but good luck with that. Now, how many cables are like that? Like, again, main distribution board have that, then sub powered boards have that. So all those sort of scenario, it will be too tedious, too impractical, too dangerous to even try to do. And then we come to crux of the matter. Even if you can do it, you should not do it, because it's not safe for high amp draw equipments. Meaning in some scenarios, if you have high current draw, it could slowly melt. Now, like, isn't copper like very stable in very high temperatures? Absolutely. That's why it's used in electrical system. Here's the solder is inherently not. It's inherently designed for low voltage systems. Inherently, it will melt before the copper does. You do not want that. Unless you are designing in such a way, it's designing inside a fuse. That's a different thing. It's a thermal cutout switch. It's a different thing. But you do not want your plugs to behave that, meaning everything should fail basically after the fuse have failed, not before the fuse have failed. But if you have solder, it could have that sort of scenario, specifically in high current draw. That's why solders are not acceptable for high current draw applications. And it can also do what we classify as cold flow. Now, that will not happen overnight, but if you are doing a house wiring, how many times you're supposed to tamper with it? Almost never. So that's the whole expectation here. Is like cold flow will happen, heating and cooling. Your house has different power requirements, different heating and different cooling. Over time, you will find out the solder has flown away. It has happened. It has caused shorts. That's why it's like, thou shall not touch it. You go to any industrial power system, power distribution board, and you will never find solder. If you have find solder, run. So that's the problem with it. Specifically stranded wire. Now, like, why can't we use solid core? It acts like a rod. It's very difficult to manipulate, and it's very fragile also. So if you kink it too many times, it will bend internally and you have to throw away the cable. And if you are talking about anything that has like a lot of power draw and requires flexibility, let's say your car terminals or car whole audio equipments, that's why they have to use. And car scenario is really brutal, so they have to use fine stranded wire, which is really bad. So again, if you try to screw fine stranded wire, good luck. So what we do, we utilize what we classify as ferrule. Now, ferrule is a thin metal crimp barrel with or without insulation. So basically, it could be without insulation, just for things generally used in plugs, meaning things that are supposed to go in here. If you have to design that, you do not have a space for the shoulder, so to say. So it will be without insulation. But if you have the space, you will find that with insulation. Now, what about the color code? People say there is no color code. Well, there is. Problem is there are 3 goddamn color code. There is German, French, and whatever else. So that's the issue. That's why you may feel like the color code does not make sense. So this is very thin metal tube. Now, what does it do is basically take a cable like this, make it into one solid conductor for all purposes. Meaning, if you tighten up the screw, it will not fan it out. And that's the biggest problem with this sort of open wire system. Meaning, even if you fold it up, it will nick it there, it will damage it there, and then the cables will fan out. And that creates a serious hazard. Enough buildings have been set on fire that people are like, thou shall not do it anymore. So flat out, binding them all into one pipe, so to say, makes it stable, and it's very easy to use. It's like reliable. You pull it out, you pull it in, you pull it out, you pull it in. If you are troubleshooting, that's a very desirable system. It has no risk of falling out, meaning it will not oops out of it. It can be redone. That's also awesome. Maintenance is easy over time. This is one thing that separates low level amateurs from professionals. If professionals are working on something, be it electrical, be it audio, be it car, they will design in such a way that you can rework on it. Now, like, professional will work in such a way that it will never broke. Come to real life, that never happens. And even if you did everything right, what if the product was faulty? It could happen. Like, you may be like, I have mounted this MCB properly, awesome. What if the MCB was faulty? It happens. It's one of those things. Like, mean time between failure is very large number, but still happens. So then what? That's why you have to think maintenance. These sort of Ferrule makes things maintenance super easy, meaning that's why you will find this sort of terminals, whole terminals in your battery systems, because you can just open it out, replace a new one, done, go home, sweet dreams. Don't think too much about it. Makes it reusable as many times as you have to. And if you are building, let's say, a 3D printer, CNC machine, if you have this sort of system, you can keep doing it as many times as you need it. Ferrules, as many times as you need it. But if it was raw cable, good luck after a few tries. Not even few, 2-3 times you will start to run out of cable length. So that's why we use ferrule. Now, how do you crimp the goddamn ferrules? They require very serious engineering. Now, what kind of engineering? If you have right crimping, you can achieve what we classify as gas tight, meaning if you look under the microscope, there is no place for oxygen to react, meaning some oxygen was present when you are making the crimp, but after that, nothing. Meaning it will not oxidize, even if it has two different material, meaning outer could be aluminum and inside could be copper. If done properly, it will still not oxidize. So that's awesome. It's a super corrosive resistance, and mechanically it's much stronger. Compared to raw cable, of course, it's stronger because all the small strands are behaving like a one giant block. GG. Solder, again, solder is inherently a different alloy, inherently designed to be soft and low temperature. So inherently it's much weaker compared to a crimp system. That's why crimps are used in battery terminals, high voltage DC. Crimps are like, I got you, fam. Raw cables and all that. Now, proper crimping is very hard to do, even if you can buy crimp tools like this. Now, these sort of crimp tools are very cheap, 1,000 rupees. But if you go from any branded which has like proper certification paperwork, it's very expensive. Now, why is that? Well, fundamentally design would be the same, but thing is, the crimping pressure is something very tightly controlled. Only then you can achieve this. Only then you can be like, it's gas tight. Otherwise, still much better than having raw cable, flat out. Let me be very clear. Even a cheap one is better than having, like, no crimps. But be mindful when you look into, like, let's say you're opening a factory or building some tools and you're like, hey, I want crimped cables, and you're like, dude, the machines from Siemens are costing like few $1 million. Why is that? Crimping, making a proper crimp that is gas tight is very expensive to do. Cheap ones are okay, they can get the job done, and if you are thorough with it, vigilant with it, and if you are making sure it's not wearing out, because the jaws that are required to fold them properly is very tedious to design. So, and there are many types of crimps. Some are insulated, some are raw, some are plug, some are fork, some are ring terminals. A lot of options are there, and this sort of system you will find high amped raw with fine stranded wire. Again, these are tedious things to do, but it is compulsory to do in those sort of scenario. And if you are using your tools properly, then it will be safe. If you are not using properly, then you can't blame the crimping tool or this. Even cheap ones, if you take your time, test everything, thoroughly verify it. And again, if you are running a company, people will sacrifice, like, this sort of system, cut the disc and see. They will see it under microscope. Is it achieving this sort of system or not? And there would be a tolerance. Again, no machine can be like absolutely perfect 100% of the time, but there will be a tolerance factor by country's laws and regulation based. Like, bro, 90% should be like this, 10% okay. But again, you have to check it. So you have to sacrifice super expensive cable and super expensive crimps in order to test it. It has to be done in real life. So that's why crimping is, while not as popular as you might think, it is an expensive thing to do. What about industrial? Now, this is one thing where crimping is like, it was always there. It was always there, as in, like, back in the good old days, it was always there, because there was no other option. There is no other way where you're gonna even try to solder 100 square mm cable. Good luck trying with that. Like, there is almost nothing that will do that. And if you put that much heat that is required to soak solder into it, you will damage the insulation. So fundamentally, there is no other option. You have to do that. High power. Now, how do you get that cold welding sort of system? Well, you have to use either hydraulics or you have to use electrical. Human hand simply does not have that power. I cannot just, like, do this. That's not gonna work. So fundamentally, it does require a bit more oomph to it. And there are strict guidelines from cable manufacturers to ferrule manufacturer to clamp manufacturers. Everybody will be like, we have to work with each other. Only then we can certify the cables to carry like hundreds of amps, 200 amps, 1000 amps. When you are talking this sort of amps, that matters, because if you have one faulty crimp, good luck. And you will always notice that whenever they are crimping it, they will crimp it twice. There is no chance. One is more than good enough. Electrically, one is more than good enough. But they're like, thou shall always have two. You do not take risk. You do not troll around with it. You have to do that. And nobody thinks about saving money. Again, when I'm talking about household and compared to raw cables, this is very good. When you're talking about this sort of system where you have hundreds of amp, or if you're talking about industrial robot which is used to in your car welding machine, you will not save a few $100 just to risk a freaking $1 million robotic arms. Nobody is thinking about saving money. It matters a lot. And not to mention, think of this way, let's say this equipment faults, no problem, remove the screws, yoink the material, put a new one in, don't think too much about it. That's why it matters. Time matters. So designing it such a way that it can be maintained, repaired reliably again and again, it makes it sure that your industrial box is not something that after 2-3 maintenance companies is like, yit, thou shall never buy from them again. So that is one of the very important things. And if time and care is taken properly, it will last for a very long time. And that's why whenever you think about any household fire, it's always household. Why the heck it's rarely industrial sector? And industrial only happens if somebody else messed it up. And generally on the equipment side, rarely on the power distribution side, because they take the time and effort needed to get it right. And not to mention, they generally dealing with such a high amp, the tolerance are very, you mess a little thing up, it's like, I'm going to tell you that you messed it up. And the first moment is going to tell you. The moment you turn on the main breaker, boom, has happened. So where are these sort of things are used? Well, reality is everywhere. So from small to small equipments to very big equipments. Small equipments, people are utilizing that now in distribution board, where you have basically transformers for current reading, CT transformers. Whenever you are talking about like 3D printers, my 3D printer has that again. You may even find this sort of system inside your computer power supply, CNC machines, all that jazz, like small to small equipments. Not even too expensive one, they are using it. And expensive one, again, if your equipment is expensive, you're gonna spend some money to get some proper crimps done. And why do people do it? Can you live without it? Yes, there are some laws that allows you to get certification even without it, but you have to understand it. Peace of mind, what is its worth? That's up to you. Can you utilize this cable? Absolutely. Can you utilize this one? Absolutely. Now, will you save money and time if you do not go with this? Absolutely. Then why go with this? Well, it will give you peace of mind. Meaning, if you have a scenario, let's say you shipped out, let's say Ender 3, and all your cables were ferruled, and you had a scenario where this main board is faulted out, how quickly you can get the unit from the customer, swap the unit out, send it back. How quickly can you do that? If it's ferruled, super easy. And again, you can even have a technician go to their household and get it fixed in few minutes rather than few hours. And that's, yes, that matters. And not to mention, like this is a Havells Indian switchboard manufacturer, and you can notice that they are spending time to get it crimped done, because nobody trusts electricians anymore. They're like, dude, let's do it right from factory. And you will notice that more and more equipments are coming with ferrules from day one. So industrial electrical box, they have to have it. CNC control, robotics arms. If you go into this sort of field, you will find that everything is properly crimped. You have to, there is no alternate. So you have to. House distribution box is also very important. And these are like giant capacitor banks used for power factor correction. And it's surprisingly well done. This is one of those things I never knew what is its importance was. It's one of those things, yeah, everybody's like, I need quality plugs. I'm going to use quality C13 receptacles into that. Awesome. What about the cable behind it? If this part is weak, all you did is shifted your fire hazard from this to this side. Not good enough. So that's why this sort of equipment and this bad boy, I'm genuinely sorry that I could not show you, because even though I did order it, only this part arrived. The ferrule box did not arrive. So I'm really sorry about that. But again, I will try to make a shot of it. So that's why there are a lot of users of it. And if you are not aware of this, I would urge you to watch the videos that I've linked down below and get familiar with it, because it is one of those things that could save your life. So this was one of my presentation on crimps, ferrules. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.